Get ready for a celestial spectacle. The universe is about to put on a show that you won't want to miss. The northern lights, also known as the Aurora Borealis, might soon be gracing our skies with their ethereal glow. These lights are a natural wonder, a breathtaking display of nature's beauty. A strong geomagnetic storm is headed our way, potentially pushing this mesmerizing display further south than usual. This means that even those who live in areas where the northern lights are rarely seen might get a chance to witness this phenomenon. Imagine brilliant curtains of green, purple, and red dancing across the night sky. These colors are created by the interaction of solar particles with Earth's magnetic field, resulting in a stunning visual display. This isn't science fiction, folks. It's the power of the cosmos, and it might be visible right from your backyard. Imagine stepping outside your home and being greeted by this awe-inspiring sight. This isn't just any ordinary sky show. This is the Aurora Borealis, a phenomenon that has captivated humankind for centuries. People have marveled at these lights, creating myths and legends to explain their beauty. We're talking about charged particles from the sun colliding with our atmosphere. These particles are carried by the solar wind, and, when they reach Earth, they interact with our planet's magnetic field. It's a cosmic ballet of light and energy, and it's coming soon to a sky near you. So mark your calendars and prepare to be amazed by one of nature's most spectacular displays. Don't miss this chance to witness the magic of the Northern Lights. So, what exactly are the Northern Lights? These mesmerizing displays have fascinated humans for centuries, inspiring countless myths and legends. Imagine a cosmic ballet of light and color painted across the night sky. It's as if the heavens themselves are putting on a show just for us. That's the Aurora Borealis, a breathtaking phenomenon that occurs when charged particles from the sun interact with Earth's atmosphere. This natural light display is most commonly seen in high-latitude regions around the Arctic and Antarctic. These particles, riding on solar winds, collide with gases in our atmosphere like oxygen and nitrogen. The sun constantly emits a stream of charged particles known as the solar wind, which travels across space and reaches Earth. These collisions release energy in the form of light, creating the shimmering curtains, arcs, and rays of the aurora. The result is a dazzling display that can last from a few minutes to several hours. The colors of the aurora depend on the type of gas being excited and the altitude at which the collisions occur. Each color tells a story about the specific conditions in the atmosphere at that moment. Green, the most common color, is produced by oxygen at lower altitudes, typically around 60 miles above the Earth, while red is produced by oxygen at higher altitudes, above 150 miles. Other colors like blue and purple are created by nitrogen, adding to the aurora's vibrant palette. Witnessing the Northern Lights is a humbling experience, reminding us of the incredible forces at play in our universe. It's a reminder of the beauty and mystery that lies beyond our everyday lives. Now you might be wondering why we don't see auroras every night. The answer lies in Earth's magnetic field, a protective bubble that surrounds our planet. This magnetic field acts like a shield, deflecting most of the sun's charged particles. However, during intense solar events like solar flares and coronal mass ejections, the sun releases a surge of charged particles with incredible force. When these charged particles carried by solar winds reach Earth, they interact with our magnetic field. The magnetic field lines funnel these particles towards the poles, where they collide with atmospheric gases, creating the mesmerizing auroral displays. That's why auroras are most commonly seen at high latitudes near the Earth's magnetic poles. The sun, our very own star, isn't always a calm and steady neighbor. It has its moments of drama, throwing explosive tantrums in the form of solar flares and coronal mass ejections, CMEs. Imagine giant bursts of energy and plasma erupting from the sun's surface. That's a solar flare, a sudden and intense release of energy. CMEs, on the other hand, are like massive bubbles of gas threaded with magnetic field lines that are ejected from the sun's corona, the outermost part of its atmosphere. These solar storms release a surge of charged particles into space, and sometimes, Earth gets caught in the crossfire. Section 5. Geomagnetic storms. When the sun disrupts our flow. When a CME or a particularly strong solar flare hits Earth, it triggers a geomagnetic storm. These storms are like cosmic traffic jams, disrupting the flow of energy and particles in Earth's magnetic field. Imagine a sudden surge of electricity coursing through a power grid. That's what happens to our magnetic field during a geomagnetic storm. The intensity of a geomagnetic storm depends on the strength of the solar storm that triggered it. Strong geomagnetic storms can cause auroras to be visible at lower latitudes, further away from the poles. They can also disrupt radio communications, GPS systems, and even power grids. Understanding the G-scale from minor flickers to major light shows. The mesmerizing dance of the auroras in the night sky is not just a visual treat, but a complex phenomenon that scientists have been studying for years. To measure the intensity of geomagnetic storms, scientists use a scale called the G-scale. This scale helps in understanding the potential impact of these storms on our technology and daily lives. This scale ranges from G1, minor, to G5, extreme. Each level on the G-scale represents a different intensity of geomagnetic activity, with G1 being the least severe and G5 being the most extreme. A G1 storm might cause weak power grid fluctuations and minor impacts on satellite operations, while a G5 storm can cause widespread power outages, satellite failures, and stunning auroral displays, visible even at low latitudes. The effects of these storms can vary greatly, impacting everything from navigation systems to communication networks. The upcoming geomagnetic storm is predicted to be a G3, which is considered strong. A G3 storm can lead to more noticeable disruptions, such as voltage corrections in power systems and increased drag on satellites in low Earth orbit. This means we can expect some noticeable effects, including potential disruptions to power grids and satellite operations. People might experience minor inconveniences, but the scientific community will be closely monitoring the situation to mitigate any serious impacts. But more importantly, it means we have a good chance of seeing some spectacular auroras. These natural light shows are a reminder of the powerful forces at play in our universe, and they offer a unique opportunity for people to witness the beauty of our planet's magnetic field in action. The unpredictable nature of space weather. Just like Earth's weather, space weather can be unpredictable. While scientists can monitor solar activity and issue warnings for geomagnetic storms, the exact timing and intensity of these storms can be difficult to predict. Think of it like forecasting a hurricane. We can track its path and intensity, but there's always a chance it could change course or intensify unexpectedly. The same goes for space weather. The sun is a dynamic and complex object, and its behavior can be unpredictable. So, while we can prepare for geomagnetic storms, we can't always predict their exact impacts. Preparing for nature's light show. With a geomagnetic storm on the horizon, it's time to get ready for a potential aurora show. If you live at a high latitude, now's the time to start checking the aurora forecast. But even if you live further south, don't lose hope. This storm is predicted to be strong, so there's a chance the auroras might be visible even at lower latitudes. To increase your chances of seeing the aurora, find a location with minimal light pollution, away from city lights. Dress warmly, as auroras can last for hours, and be patient. Download these apps, your guide to the Aurora Borealis. Want to know when and where to see the northern lights? There's an app for that. Several apps like My Aurora Forecast and Alerts and Space Weather Live provide real-time information on geomagnetic activity and aurora forecasts. These apps use data from space weather satellites and ground-based magnetometers to predict aurora visibility based on your location. They can send you alerts when auroral activity is high in your area, so you don't miss out on the show. Capturing the moment. Photographing the northern lights. If you're lucky enough to witness the Aurora Borealis, you'll want to capture its beauty for posterity. Photographing the northern lights can be tricky, but with the right equipment and settings, you can capture stunning images of this celestial display. Use a tripod to keep your camera steady during long exposures. Set your camera to manual mode and experiment with different aperture, ISO, and shutter speed settings to find the optimal exposure for the auroral display. And don't forget to bring extra batteries, as cold temperatures can drain battery life quickly. Share the wonder. Spread the aurora joy. Seeing the northern lights is an awe-inspiring experience. It's a reminder of the vastness of the cosmos and the incredible power of nature. So if you're fortunate enough to witness this celestial spectacle, share the wonder. Share your photos and videos on social media, tell your friends and family about your experience, and spread the aurora joy. The northern lights are a reminder that there's still so much to discover and appreciate about our universe. So, keep looking up, Keep exploring and never stop being amazed by the wonders of the cosmos. Like and subscribe for weekly videos. Like and subscribe for more amazing content.